Welcome to Chem Help ASAP. We're now going to talk about how to draw hybrid orbitals. We'll practice a little bit on atomic orbitals and then in later videos move to molecular orbitals. So we have our 4 atomic orbitals on our atom, whatever that atom is, and we have our s and 3 p's, and we'll take our s and p, we will combine them to get 2 new hybrids, 2 new atomic orbitals, 2 sp orbitals, plus our leftover p orbitals. So we have started with 4 atomic orbitals, and we get out 4 atomic orbitals. Now, when we mix these atomic orbitals, we're mixing them. We are mathematically doing operations on the wave functions of our s and p orbitals. That's psi s and psi p. And there are 2 ways we can do this. We can say it's s plus p or s minus p. And more specifically, psi s plus psi p or psi s minus psi p. And so this is how we create our 2 hybrid atomic orbitals. So let's look at s plus p, and I'm going to keep this on the y-axis, which is typically the horizontal axis. So here we have on our atom, we have an s orbital. And these pictures get messy, I apologize. So this atom has an s orbital, and that has a positive sign. And then on that same atom, we're not bringing in another atom, we have a p orbital overlapping on the same atom with the s orbital. And one side of this p orbital is shaded, positive, and the other side is negative. Well, when we mix these 2 together, add them, you see we get constructive overlap on that side. So what does our new atomic orbital look like? Well, on the right-hand side, we get good overlap. So that side gets bigger, and on the left-hand side, in this region where we have plus and minus together, it gets smaller. And so this is how people typically draw an sp hybrid. And so this is psi for an sp hybrid. And it's oriented in one direction on our y-axis. Now let's look at s minus py. S minus py, well, we got the s. And again, s minus py is kind of the same as s plus negative of the py. So let's just flip our py. Instead of having the right-hand side shaded, now we'll have the left-hand side shaded. Now when we mix these together, here's our constructive overlap. It's on the other side. And so now the positive end is sticking out on the left, and the negative tail is off on the right. So this is our another psi for sp. It's really s minus p, but this is another wave function for another sp hybrid orbital. Note that they stick in opposite directions on the y-axis, and so when we see bond angles of 180, this is why we see a bond angle of 180, because these orbitals are sticking in opposite directions. All of our hybrids look roughly like these. We have a big positive end and a tiny tail. So what people say is sp hybrids are 50% p. So half of the property came from the p orbital. And therefore, the orbital that people draw tends to be a little fatter and stubbier because it has less p character. The p character gives it the elongation. As you go to an sp2, people say it now has 67% p character. It's 2 part p, 1 part s. And therefore, the orbital should get a little bit longer and a little bit narrower. It looks more like a p orbital. And once we go to sp3, we are now at 75% p character. And they say the hybrid is longer still, and it kind of looks like that. But from a qualitative standpoint, they all sort of look the same. There's a little bit of difference in how long they are or how skinny they are, but they're all kind of the same thing. So this is how we can talk about drawing our hybrid orbitals based on what we know about mixing overlapping wave functions.